Today is day 28 of Python Pro from CTC. Today we are going to learn sorting algorithms. Sorting is akin to bringing order to chaos. Much like organizing a library, it enhances the efficiency of data retrieval, search operations, and analysis. Whether you are managing a to-do list, a playlist, or massive databases, sorting plays a pivotal role in making information more accessible and manageable. Let's see bubble sort. Bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. The pass through the list is repeated until the list is sorted. So here's an example. So here we got an array where the elements are in the order of 9, 7, 5, 3, and then 1. So we are going to compare adjacent elements and swap them, right? So we will compare 9 and 7 first. It is not in the correct order. We should swap them, so it will become 7 and 9. Then we will compare the next two elements, 9 and 5. Again we will swap it. Again we will compare 9 and 3, swap. 9 and 1, swap. In the first iteration, the 9 got in its right place. Next, the next iteration, again we will start from the first. 7 5 swap, 7 3 swap, 7 and 1 swap, but 7 and 9 we don't have to swap it. So the last two elements of this array is sorted now. In the next iteration, again 5 and 3 swap, again 5 and 1 swap, 5 and 7 we don't have to swap anything, so it is sorted. In the last iteration, 3 and 1 we are going to swap it, 3 and 5 no swap. So we have got a sorted array here. So this is how sort works. To recap, we will be comparing adjacent elements till the element is in its right place. So here we have got 9 in its right place, then 7, then 5, then 3. So 1 will be in the right place by itself. Implementation of bubble sort. Here we have created a function called bubble sort where we are passing the array as an argument. We are storing the length of the array in a variable called n. Then in the outer loop for I in range of n minus 1, that is n iterations here. Then for j in range of 0 comma n minus I minus 1. This is the declaration of the inner loop. The loop variable j is used to iterate over the range of indices in the array. The loop runs from 0 to n minus I minus 1. The reason for this range is that each iteration of the outer loop, which is controlled by I, the largest unsorted element is guaranteed to have moved to its current position at the end of the array. Therefore, there is no need to compare and swap elements beyond this point. After the declaration of the inner loop, we will be comparing adjacent elements. That is, for example, we will be comparing 64 and 34 here. As 64 is greater than 34, we will be swapping those. So array of j comma array of j plus 1 is equal to array of j plus 1 and array of j. That is, we will be swapping the value of array of j for array of j plus 1 and array of j plus 1 for array of j. So 34 will be going here and 64 will be going here and 34 will be coming here. Let's run this and see what happens. I have printed the unsorted array here, then I have ran it through the bubble sort, then I have printed the sorted array here. Let's see what happens. So here we have got the unsorted array, then we have got the sorted array. Let's try and print this. We don't need this anymore because we will have the sorted array at the end of the loop. Let's see how this works. See, as we can see here, this is the first line is the unsorted array. This got swapped. Then 64 and 25, this got swapped. Then comparing these to 64 and 12 got swapped. Then again 64 got swapped. Then again 64 got swapped. And we are coming to the next iteration. Comparing these two, 25 got swapped, 34 got swapped, again 34, again 34 got swapped here. Then the next iteration goes 12 and 25, there is no swapping here. Then 25 and 22 swapping occurs. Then 25 and 11 again swapping occurs. Then the next iteration 12 and 22, 12 and 22 no iteration. 22 and 11, 11 comes first. Then 22 and 25 no iteration, no swapping. Then 12 and 11, 11 comes first, swapping occurs. So now we have got the whole sorted array 11, 12, 22, 25, 34, then 64. Merge sort. Merge sort is a divide and conquer algorithm that divides the input array into two halves, recursively sorts each half and then merges the sorted halves. For example, here we have got an array which will be cut into divided into two halves. Then that will be divided into two halves. Then that will be divided into two halves until we have got only one element per array. Then it will be sorted and then merged. So here we have got 5 and 1. It will be merged as 1 and 5. Here we have got 7 and 3. It will be merged as 3 and 7. So these two will be merged as 1, 3, 5, 7. Here we have got 2, 8, 6 and 4. 2 and 8 will be merged as 2 and 8 itself. But 6 and 4 will be merged as 4 and 6. Then these two arrays will be merged as 2, 4, 6, 8 into a single array. Then what happens is these two arrays will be merged. So we'll have the final product, the completely sorted array. In bubble sort, we will be swapping adjacent values, but in merge sort, we will be dividing the array first, then we will be merging after sorting them. Implementation of merge sort. Here we are creating a function called merge sort where we are passing an array as an argument. If the length of array is greater than 1, we will be splitting the array in half. Then we will be storing them as left half and right half. Then we will be doing this recursively because merge sort by itself is a recursive sorting algorithm. So we will be doing this till the length of array is greater than 1. That is having only one element per array. I equal to j equal to k equal to 0. This is cause we are having three index values for three arrays we have. The left half, the right half and the array itself. So we'll be comparing the left half and the right half, that is the elements in the left half and right half, to sort them. So while I, that is the index, is lesser than the length of left half and the j is lesser than the length of right half, we'll be comparing the elements of left half and right half, that is left half of I and right half of j. If the right half is greater, that means the elements in the left half, the element in the left half is smaller, right? So we will be storing the smaller element in the array itself. So array of k equal to left half of I. As we have added the left half, we have to move to the next element in the left half, right? So we will be increasing the index I plus equal to I plus 1. If the left half is not greater, we will be adding the right half to the array. So we will be increasing the index of the right half. Anyway, the element is added to the array itself, right? So we'll be increasing the index of the array itself. Then if I is lesser than the length of left half, array of k equal to left half of I, so we'll be doing these two operations to merge these arrays. So if we are doing the operations in the left with the left half, we will be increasing the index of the left half and the array itself. Again for the right half, we will be increasing the index of the right half and for the array itself. So let's see how this goes. So here we have got the unsorted array, then we have got the sorted array. This actually works by seeing the intermediate array forms. So I'll be printing the array in every step. and we won't be needing this because at the end it will provide us with the actual sorted array. So I'm going to run this. So as you can see here, the unsorted array, then 1537 as we have got here, this is the sorted form, not the unsorted, just the divided form, but the divided sorted form. So 153737, then it will be merged, the left half will be merged, 1357, 1 3 5 and 7. Then the right half, 2 8 and 4 6. Here we have also got 2 8 and 4 6. Then it should be added and it should be sorted as well. So here we have got the merged and sorted form, 2 4 and 6 and 8. Then these two arrays should be merged. As we have saw in this example, we have got this merged and sorted array. This is how merge sort works.